Hi everyone, today's goal is to find the percent of change. The percent of change is the percent a quantity increases or decreases from its original amount. The percent of change is found by taking the amount of change, which is the same thing as the difference. You're going to subtract your original amount from your new one, or vice versa, because it's always going to be a positive number, and you're going to put that over the original amount. Do your division, and then since it's percent, we're going to multiply that answer by 100. At a supermarket, a certain item has increased 75 cents per pound to 81 cents per pound. What is the percent increase of the cost of the item? So here is our equation. Percent of change equals the absolute value of the new value minus the old value over the old value times 100. Okay, we went 81 cents from 75 cents, so we're going to subtract it. Our original amount, or our old value, is 75 cents. And then we're going to multiply it by 100. So our percent of change is an 8% increase because the cost went up. 4 feet are cut from a 12-foot board. What is the percent decrease in length? Again, here's our equation. And be careful, it says 4 feet are cut from the 12-foot board. So our new value is actually 8. Don't get confused and use 4. Our equation becomes 12 minus 8 divided by 12 times 100. And the percent decrease in length is approximately 33 1/3%. Relative error is another term we can use for percent of change. Relative error deals with your specific estimated values and actual values. It's really just another name for a percent of change. So the relative error is the ratio of the absolute value of the difference of a measured or estimated value and the actual value compared to the actual value. I know it sounds confusing. Keep it simple though. A cube's volume was estimated to be 8 centimeters cubed. When measured, each side was 2 1/10 centimeters in length. What is the percent in error in the estimated volume? Well, the first thing we have to figure out is the actual volume. So in order to do that, since it's a cube, we're going to cube the sides. 2 1/10 times 2 1/10 times 2 1/10. And our answer is 9 261 thousandths. We're then going to put it into our formula, and we're going to subtract the actual and the estimated volume. And we're going to divide it by the actual volume. Okay, here's your next step. We've done a subtraction first. And remember, you need to be careful if you're using a calculator. Don't put it all in at once unless you put parentheses around the numerator. Otherwise, order of operations will take over, and your calculator will do the division first and then subtract it. Because it asks for the percent, we take our relative error amount, which is just this number, 136 thousandths, and we multiply it by 100, changing it to an error percentage of 13 6/10. One other thing you have to keep in mind is the difference when we round things. A student's height is measured as 144 centimeters to the nearest centimeter. What is the student's minimum and maximum possible heights? Okay, in this case, the smallest possible height that could round to 144 centimeters would be 143 1/2 centimeters. In order to do that, we're going to add a decimal on, and just think, if it's 5 or higher, we're going to round it up to 144. So you want to look at the 10th spot when you're looking for the nearest possible minimum height. To look for your maximum, you're going to think about what would round down to 144 centimeters. And the greatest possible height would be 144 4/10. So the student's minimum height would be 143 1/2 centimeters, and their maximum height would be 144 4/10 centimeters.